That exponential has been shifted up 5 and right 2. And that's a concept that you'll love in pre-calculus next year. Okay. Getting a little glassy-eyed. Next, we'll do a little science. And it won't be, yeah, this is the last example. What's half-life mean in science? To go away. Yeah, so the amount of time it takes the radioactive part of an element to dissipate, to no longer be radioactive. All right, so let's say I've copied this one out of the book. We have arsenic. It's called 74. I don't know what 74 is. And it supposedly has a half-life of 17.5 days. So we're going to start off with 50 grams of arsenic 74. Write a function. So if I'm going to start off with 50 grams, I know one point. It's called day 0, amount 50 grams. Since my half-life is 17.5 days, I know another point. At day 17.5, how many grams do I have left? No, half-life means I'll have half the amount. 25. Okay? I have 2 points. I can make a function, an exponential function. Because these half-lives use exponential functions. So I got 0, 50, so I know my A already. My A is 50. I'll use the second point to find my B. So I'll use 17.5 comma 25 to find B by using y equals A times B to the x, or 25 equals A, 50, times B to the 17.5. How do I get the 50? A is always the y-intercept. Yes. That's why if you get the y-intercept, half your work's already done for you. Yeah. Tricky, huh? All right, so B to the 17.5 is 25 over 50. Oh, that's a half. So B is the 17.5 root of 1/2. I would get that in my calculator. So in your calculator, you put 17.5, then you hit the math key, then you hit the x root key, and then you come back and type in 1/2, or you can type in 0.5. And that should give you should go to quite a few decimal places, 0.961166. So my exponential function for this half-life problem is y equals A, that's 50, times B, 0.961166, to the x power. No, don't round. Go quite a few decimal places, otherwise you'll end up not getting the right answer, because when you're doing these weird roots, you need to go quite a few decimal places. Hopefully 6 will be enough. All right. So how much Arsenic, 74 will I have in 100 days? How would I figure that out? Well, the days are the x, time is almost always the x. I'll put the 100 in for the x, and then I'll just use my calculator to calculate how much. And that's 50 times 0.961166 to the 50th, I'm sorry, to the 100th power. I'll have 0.95 grams left after 100 days. Yes, sir? Yep. Yep. Is that far enough back? Okay. Yeah. So I start with 50 grams, so I let my A be 50. And my half-life is 17.5 days, so that's how I get my second point, is the 17.5 days. Days time is almost always the x. And then, how many, and the y is going to be the grams, and half-life means that I have half the number of grams after that amount of time. So I take that 50 and divide it by 2, and that's how I get my 2 points. I didn't have to, because if I got my y-intercept, that's always the a. So I've already solved for the a. And so I just had to use the second point and plug in the a that I got and into the y equals a b to the x. Plug in the a, plug in the x, y. All I got to do is solve for the b. The 25 and 17.5. Okay. All right. Never.